Okay, welcome back. Okay, so I hope everybody had a good couple weeks off from this class at least. And so there's a couple assignments due tonight, just as a reminder that I've got most of those already. Um, the homework chapter 5, most of those are turned. Hold on one second. Okay, the homework chapter 5 is due today, so that goes in the discussions. Uh, okay, so make sure you get that posted here by the end of today if you haven't done that. Okay, and then obviously the midterm is due today by email, so I've got most of those already. But if you have not sent me your midterm answer sheet via email, then make sure you do that. Okay, so two assignments due today. Homework assignment for chapter 5 and the midterm. Okay, and so today we're gonna move on to kind of the second portion of the class, our second 5 meetings, or the meetings 6 through 10, if you want to call it that way. And so we're gonna start looking at different types of firms, different types of markets, and different types of firm behavior and how they react and stuff like that. So we're moving on to chapter 8 today. That's the chapter I'd like to cover today. And we're going to talk about some different types of markets. You might be familiar with some of these markets from BUS525 or any Intro to Economics course. We're going to talk about perfect competition or pure competition. We're going to talk about monopoly, and we're going to talk about monopolistic competition. So three different types of markets. And then we're going to spend a bunch of time on oligopoly in the next couple chapters, and those are coming up as well. All right, so I think everyone is good on getting in the midterm and getting in the homework assignment from last week. No problems with the midterm. Um, Everyone's good on that. Okay, so okay. Well, I think we'll go ahead and start getting into today's material, which is for chapter 8. So you can go to the chapter 8 section. Okay, and there's the Word document for chapter 8 and also the homework, so you can open up those two. We'll get to those in a minute. Okay, you can open up, oops, I already got that. You can open up the chapter 8 PowerPoint. All right, we'll be starting with that. And then I'll have the older PDF version of the textbook open just so I can show you some of the graphs and equations. Okay. All right, so here we go. Let's talk about some different types of markets. And so we in the first couple chapters or the first half of the class, we did like an intro, we did supply and demand, we did a whole bunch of elasticity analysis, and we looked at individual behavior, how individuals maximize utility. And last chapter 5, we looked a little bit about firm behavior and production functions. So now we're moving on to all firm stuff, different types of markets, and how firms behave or make decisions depending on the market we're in. Before we do that, we have to introduce the different types of markets. And the first one we're going to talk about is called pure competition or perfect competition. Kind of, they're both interchangeable. And then we'll talk about these other ones as well. So there's a optional video there you can look at on monopolies. All right, so let's introduce our first type of market, and you might have heard about this before from BUS525, but the first type of market we need to talk about is perfect competition, also called pure competition. All right, and so these are the conditions, or these are the characteristics, I guess, of pure competition or perfect competition. So there's many buyers and sellers. Okay, there's no limit on how many people can buy and how many firms can sell. Each firm is going to produce a homogeneous product, and that essentially means that this type of market assumes that everyone is selling the same exact thing, right? That's the assumption of the model. Okay, we're also assuming that both buyers and sellers have perfect information. Okay, that's a bit unrealistic, but it's necessary to make this assumption here. Okay, there's no transaction cost, which is also a little bit unrealistic, but it helps to prove some of the conclusions for this model. And so just kind of assume for the basic part that everyone has perfect information and everyone can make transactions without cost. Okay, and finally, there's free entry and exit. So this is a very unconstricted or unconstrained market where everyone is selling and buying the same. They're different things, but they're selling the same types of goods. So you might recall back in the elasticity section from chapter 3 or 4 that we talked about a type of demand curve that was perfectly elastic. Okay, and so when we introduce that, that's kind of the type of market we're looking at here for the perfect competition. And so this is assuming that the sellers of these goods and services are selling the same exact thing. And so remember the kind of qualifying characteristic for those goods and services when we looked at the example of perfect competition was that they're perfect substitutes. Okay, and remember, I think some of the examples I used, or the main example I used was kind of agricultural goods that you could buy or sell at a farmer's market. Okay, and so that's kind of the idea for this type of model. So perfect competition, we're going to see that really the firms have no market power and really no control over price, and price is set by demand in the long run situation, and that there's a price set by the market, and firms can either if they're selling that good, they can either sell at that price or not sell. They have no control over price. Okay, so if we look at the next slide here, so because of the type of market where there's perfect information and the firms have no control over price, the demand curve is going to be just like I talked about. It's going to be perfectly elastic. And so in a competitive firm or a perfectly competitive firm, the demand curve for an individual firm is going to be just a perfectly elastic horizontal line at the market price. And so I'll show you what the picture looks like, but it's basically going to be a perfectly elastic demand curve for each individual firm. And so the demand curve is going to be flat, at the price, which is basically set by long run situations by demand. Okay, so it'll look kind of weird at first, but the demand curve is going to be a perfectly horizontal line at the market price. Okay, and I'll show you how this works out here. Okay, so if we look here, all right, so this first graph is very important because it explains the situation. So we're talking about now the demand curve for an individual firm in perfect competition. Okay, so here's a nice little example. So again, this is like let's say this is a firm selling apples at a farmer's market. Okay, so you got two panels on this graph. So there's the market and there's the firm. So the market looks just like you'd expect. You got the upward sloping demand curve. The upward sloping supply curve and the downward sloping demand curve. So supply and demand like we're used to here. Okay, here's the market. But each firm doesn't have any control over price. That's set by demand in long run situations. And so see how this is the market, right? And so this is supply, and this is the supply of the whole market, and this is demand for the whole market. So those forces, right? The equilibrium here sets the price, and see how the price goes over here. And so that price is given or an option for the firm. So if a firm wants to sell, in this case, apples, they have to sell at this price. All right. So the idea is pretty simple that this is what demand decided they will pay. All right. The demand can go up or down in the long run, but in the short run situation, the price is set. So here's the price of apples. This is what, for the same quality of apple, this is what individual consumers will pay. Okay. And so basically, an individual firm has no control over that price, right? So they can either sell apples at that price or they can not sell. So really their only choice is uh, do they sell and how much do they sell? Okay, and so you can see if this is the price PE that consumers are willing to pay right now for apples, all right, assume all apples are the same, then the firm can choose how much they want to produce at that price. So if they try to sell above the price, remember these are perfect substitutes. If you're selling the same exact product, the same exact apple at a higher price, no one's going to buy it because they can buy it at a cheaper price. And you wouldn't sell it below market price because you're not going to cover your costs. So this is the price, at least for now, unless things change. Firms in this type of market have no control over price in the short run. So they either sell at this price, don't sell, and if they sell, they choose how much they want to produce. Okay? So this is the important link between the market and individual firms, where the demand curve for an individual firm is perfectly elastic, like we talked about in chapter 3 or so, and see how this individual firm demand curve is flat at the determined market price. Okay, and so see this condition here where demand equals price. We talked about that. Now, in this situation, it's a little bit unique where demand and price are also equal to marginal revenue. And what that means, if you look at this graph, okay, so each time the firm sells one more good, they get the price they charge of it. So if the price is set here, if they sell another output, they get price times quantity. But what you can see is the price is constant, right? And so each time they sell one, they get an extra price times quantity. If they sell two, they get another, you know, the price here, all right? So each time they sell one more unit, they get this much revenue, the price. Now, because that price is set, each additional unit, like each extra unit sold, is the same. They get more revenue, but each on the margin, each one is the same. So they get if let's say this price is $10, or no, we're talking about apples. Let's say it's $1. Okay, so if the market price is set at $1 for an apple, then each apple the firm sells is an extra dollar, right? It doesn't matter. So if they sell one apple, they get $1. They sell two apples, they get $2. They sell three apples, they get $3. Each marginal apple gives them the same extra revenue on the margin, which is the price. So you see how the demand curve and the price and the marginal revenue curve are all the same thing uh, in this type of market. Okay, so a very important condition that holds for this market only, which is that demand equals the price equals marginal revenue, because that perfectly elastic horizontal demand curve for this type of market. Okay, so let's talk about how a firm would make decisions under this. So normally, for all the other types of markets, there's gonna be two decisions the firm makes or could make, which is how much do they sell and what price do they charge. Now, this type of firm doesn't get to choose the price because that's set. They don't have any control over the price. That's set by long run demand, and so the only decision is how much they sell. So basically, should they compete and how much should they sell? The price is set. They can't control price, but they can determine and can decide how much output they want to sell. Okay, so basically, in the range at which marginal cost is increasing, um, the firm is going to sell, or I guess all firms are going to sell really at the situation where on the margin revenue equals cost, and so the condition I'm going to keep uh, telling you guys about is this. Okay, so the profit max condition for choosing how much quantity to sell is this. So this is always going to hold if the firm can find it. It's where marginal revenue. So basically, they're gonna choose Q or Q star, where marginal revenue equals marginal cost. Okay. So basically, what I'm saying is that all firms should. Okay. So basically, all firms should choose Q star, their optimal output, at the condition where MR equals MC. And so that's again, this is a hypothetical. Now, I'm not saying that every firm is going to have this equation. Look at this condition every day and say we have to, no matter what, we have to make sure MR equals MC. But what they can do is I mean, think about the condition first. So if you're at the condition, if you're below the condition, it probably means that your revenue can be increased. So if you're below that condition and one more unit gives you more revenue, you're gonna sell that extra unit because you're gonna get more revenue. Now, if you go beyond that condition, you sell too much, then each extra unit is going to cost more than the extra revenue, and so therefore you're going to want to cut back. So you can see that selling output below this condition, like selling less output than this condition, you can get more revenue by selling more. And selling output beyond the condition, like selling too much, it's costing you more per unit than it is getting revenue back. So that's bad too. So it's only when this condition holds that you're doing your best. Now it's hard to always. I mean, I'm not saying that every firm is exactly doing this, but they do have meetings and they have decisions and they look at spreadsheets and they say like, okay, we last month uh, we sold more units and we lost money. We should probably cut back. Or every time we sell more, we're getting more revenue. We should sell more. So they know that basically if they have a situation where they're increasing output and getting more revenue and it's covering costs, they're going to keep selling more. Or if they get to a point where they're selling too much and it's too costly, they're going to cut back. So it's hard for this condition to hold exactly, but the principle is very clear that this is what most firms are trying to do. Okay, now to bring it back to this type of market, perfect competition where we have this perfectly horizontal elastic demand curve. So we want to find the point when MR equals MC, but I just showed you that MR equals price, right? Because the price is constant and each marginal unit sold gives you the same price, and therefore MR equals price. So if MR equals price, we can plug it in to this condition for this type of firm only. So since sorry, that should have said if price equals MR, not or that one. Okay, let me start my statement over here. So okay, so for perfect competition, so if we want the profit maximizing condition that we talked about, where MR equals MC, but for this type of firm, remember we just discussed it, price equals marginal revenue, okay? That we can plug in price for the MR in the condition, and so basically if we want MR equals MC, but price equals MR, then just plug in price for MR and we get price equals marginal cost. So for this type of market, we want the condition where MR equals MC, but because MR always equals price, then you can just simplify it to this. So this is also saying that MR equals MC, but because price is MR for this type of market, just plug in that there. So this is the profit maximizing condition for a perfect competition firm. Okay, so we're going to look at an example here. Okay, everyone doing okay so far? Good. All right, so in the Word document for Chapter 8, I have a bunch of practice or a bunch of demonstration problems solved. So let's look at the first one, demonstration problem 8.1. Okay, so you got some optional videos on the different types of markets we're talking about. Perfect competition, we're talking about now. Monopoly, we're about to talk about. And the last one for today is monopolistic competition, the end of chapter 8. Okay, first example, demonstration problem 8.1. The cost function for a firm is given below. If the firm sells output in a perfectly competitive market and other firms in the industry sell output at a price of 20, what price should the manager of this firm put on the product, and what level of output should be produced to maximize profits, and then how much profit will be earned? So we got three things. Given this cost function, okay, 5 plus 2q squared, what price should they charge, and how much output should they produce, and what's the profit? Okay, so the first part is easy because this is a um, perfectly competitive firm and they're price takers. This is the price everyone's charging, so they either have to charge that price or not sell. So for perfect competition, the price is given. The price is 20, so they're going to charge $20. Okay, and we also know for perfect competition, price equals demand equals MR. Right? That's the condition for that horizontal perfectly elastic demand curve. Okay, so what you want to find here is how to calculate marginal revenue and marginal cost. So for this one, it's easy because marginal revenue is just equal to the price. All right, so you have that, but you need to know how to calculate marginal cost from the cost function. So the cost function is 5 plus q squared. So this is the fixed cost, and this is the variable cost. Now, differentiate that, if you differentiate the cost function with respect to q, right? So when you change q, what's the resulting change in cost on the margin? And all you have to do there is differentiate the cost function with respect to q. Okay, so this doesn't change this is fixed, this part, the 5. So that doesn't change with output. But if you differentiate this with respect to q, you just get 2q. Okay, so basically, okay, so if you don't, if you're not comfortable doing the derivative and doing the calculus, you're welcome to look at the chapter, and they have formulas to get the marginal cost from. So if the cost function is this, then the marginal cost is this, right? Given the A's and the B's. Um, but I'm just going to go ahead and do the derivative because it's a little bit easier for me to show it that way. So either when we're doing the like marginal revenue and marginal cost, the easiest way is just to do the derivative of the output with respect to the cost or the revenue. But if you need a refresher, just look at the chapter here, and it kind of shows you the equation for marginal cost if you have a cost function like this. So look at this here. So our cost function was 5 plus q squared. Okay, so if the cost function is basically f plus q squared, right? Then just your marginal cost function is going to be just bring the 2 down and subtract 1. So if you look at the general formula for the cost function with the parameters, you can just use the marginal cost equation here, or I think the easiest way is just to take a little derivative and differentiate the function. Okay, so here's our cost function. If you differentiate that with respect to q, you get 2q. Okay, so the 5 doesn't affect anything. There's no variables. The 2 comes down, and 2 minus 1 is 1, so we just get 2q. Okay, so do we see the calculus there of how this, if you differentiate this with respect to Q, that's just 2Q, kind of like we did in the chapter 5 stuff? Okay, so, all right, so for pure competition, so here's the profit maximizing condition, MR equals MC. For perfect competition, MR is equal to price, so we have that. And we need to calculate marginal cost, which we just did. So marginal costs, differentiate the cost function with respect to Q. Here's the cost function, and MC is dQ, d this dQ, which is 2Q. Okay, so marginal cost is 2Q, and price is 20. That was given. Okay, so we want the condition where, all right, so we want the condition where MR equals MC. We know that price equals MR in this situation. Okay, so we want price equals marginal cost. Price is 20. That's given up here. And we just calculated MC, which is 2Q. So our profit maximizing condition where we want to choose Q is where 20 equals 2Q. And now just solve for Q. Divide both sides by 2. And our optimal Q star is 10 units. Okay, so the price is 20. The output for this firm is 10. And to calculate profit, okay, so profit for a firm is just total revenue minus total costs. Okay, right? Just revenue minus cost is always profit. And this symbol here, this pi symbol, is the profit symbol in microeconomics. So if you see this pi, that just means profit. That's short for profit. So profit is total revenue minus total cost. Total revenue is just the price. We're only selling one good, so it's the price of the good times quantity. So price times quantity is revenue. And we want to subtract cost, which is just the cost function. Okay, so this is revenue minus the cost function. And now just plug in the things you already got and see what the profit is. So price is 20, Q star is 10, minus the whole cost function, 5 plus Q squared. And remember you subtract the whole thing, so make sure you distribute the minus because you have to pay the fixed cost and the variable cost. So we get price times quantity minus the cost function. 20 times 10 is 200, minus 5, minus, put in Q there, 10 squared, and we get 200 minus 5 minus 100, which is a profit for this firm of $95. Okay, so we'll do a bunch of these, but that's kind of the idea is for whatever type of firm it is, you want to find the price, you want to find how much output they want to sell, and you want to find their profit, or if they're taking a loss, you want to calculate that. So uh, try to get familiar with finding MR equals MC, figuring out the optimal output, the optimal price, and then how much revenue the firm, or how much profit the firm earns. Okay. And so again, um, if you need some refresher on your calculus to calculate the marginal things like marginal cost and marginal revenue, um, I'm happy to help you with that as well. But see, I want to make sure that everyone is comfortable with taking derivatives of the functions here. So um, if you need some help with derivatives and a little bit of calculus refresher, then let me know, and I'm happy to help set up some office hours and help you do that. Okay. Questions on that one? The first demonstration problem, 8-1. Okay, next thing. All right, so now we've decided how the firm should, so that this is still perfect competition. So the firm is a price taker. They choose their output at the price if they want to sell, and then they calculate their profit, if any. So now let's see. So we know how the firm does that, but let's see just initially, like, is it where's the cutoff line for the firm actually deciding to participate in this market? So this is very important. Where the principle here. Okay, so to maximize short run profits, a perfectly competitive firm should produce in the range of increasing marginal costs, where price equals marginal cost. So we did that. And given that price is bigger than average variable cost. So if that condition holds, then what we just did is what the firm's going to do, take the price, choose their output, and calculate their profit. Or in some cases, they're going to minimize their losses. But if the market price is set below the point where their optimal Q is a price where it's below their average variable cost, they're not going to cover their costs in that condition, and so they're going to shut down. So this is the cutoff point. So basically, if the when they're choosing their output, when they choose their best output, if at that best output price is bigger than average variable cost, they're going to produce and either make a profit or minimize losses. If the price at that optimal point is below average variable costs, it's not worth it to keep producing, and they're going to want to shut down. If it's exactly equal, it's a break even. Okay, so this is the condition you want to check if you're this type of firm. If the price is high enough for you to make enough return on any revenue to cover your costs. Okay, so if the price is bigger than the average variable costs, keep producing. If it's less than, shut down. And let me show you the graph, and you'll see kind of why this is the case. All right, so you might have seen something like this in BUS525. So this is price or this is dollars on the y-axis. This is output. So price and quantity, just like demand curves and supply curves. So this is a perfectly competitive firm. So here's the price, and here's the demand curve. So the demand curve is perfectly elastic at the price. So we know that. Okay, so here's our demand curve. Now, marginal costs. So just to as a reminder, marginal costs because of the you know re- economies of scale, or not economies of scale, but diminishing returns. So the concept of like so the reason why the both curves kind of dip down and then increase is basically because of diminishing returns. So at first, uh, like when you sell a little bit of output, it's very the workers are very productive, and then they keep producing more, and then it becomes a situation where they so basically like if I could show you that graph from hold on one sec. Oh, okay, perfect. So I found it. Okay, so remember this graph from chapter 5 from a couple weeks ago, where at first workers are very productive, right? So you get increasing returns at first, and then you get increasing returns, but they're increasing at a decreasing rate. So very productive, but less productive at each unit on the margin, and then at some point you get negative returns. So the same logic applies here, where diminishing returns explain why our marginal cost is first high, then dips low, and then the point when it flips like this is the point when marginal cost starts increasing. Okay, so let me find that graph again. Okay, so marginal cost starts here, then dips down, and then starts increasing because so basically like so think of it like when when the point becomes when each unit sold is more costly than before, there's not enough. Um, so here's you're decreasing, you're increasing, and then each additional unit is going to be more costly than before. All right, so that's the point when it flips and marginal cost starts increasing, and then average total cost, this curve here, um, because it's an average of the total, it's going to first be high, then dip down, then average out, and then start increasing. So basically the concept of diminishing returns explains why both of these curves kind of go down then up and down then up. Okay, now where's so I told you the condition to choose output Q star is when MR equals MC, and for perfect competition, that's when price. So here's MR, and here's MC. Okay, so see what I'm talking about graphically? Here's the marginal cost curve, this red curve, and here's the marginal revenue curve, this straight line. And this dot here is when MR equals MC, right? It's when both the curves intersect. So that's exactly the point in which the firm would want to choose its output when MR equals MC. And you can see how we get the profit like um, geometrically, I guess. So if this is output Q and this is the price, then revenue is price times quantity. So this price times this quantity, this whole big outer box is revenue, and cost is average cost at that output, at that Q. So this is cost. So basically, this is revenue, and the smaller box is cost, and what's left over is the profit. So if P times Q is revenue, and this white box is cost, then if you take the revenue and subtract the cost, so what you're left over with is this pink region, which is the profits. So if you can see that kind of geometrically, or yeah, like geography wise, not geography. What's the word I'm looking? Geometry wise. Sorry, not geometry. So like geometry wise, this area minus this area is what's left over, which is the profits. Okay. So this is a profit maximizing firm, which is choosing its best output Q star, where MR equals MC, and taking the prices given, and given the price and given the Q star, this P times Q is their revenue. This is their cost at the average total cost curve for this output. And so revenue minus cost gives them this profits left over of the pink region here. Okay. Now, next scenario is when, so there's let me preface it, there's three scenarios. Okay, so let me write those here. And it's like, there's actually like 1A, 1B, and then like two. So there's two things the firm could do. Um, Produce or shut down, and if they produce, they're either going to make a profit or they're going to minimize their losses. So let's just say there's three conditions. All right, so first one. Okay. So those are the three conditions I'm going to show you. We'll talk about and we'll see graphically. So the one we just saw is basically they're going to produce and make a profit. All right, that's the best case. The second scenario is they're going to produce and they're going to take a loss, but they're going to minimize their losses. All right. So loss minimization or cost minimization. And the third case is if price is too low, they're just going to shut down because each additional unit sold is costing them more money than just shutting down. So condition one or outcome one, produce and make a profit. Outcome two, produce and minimize losses. And outcome three, just shut down. Okay, so we saw just now uh, condition one where the firm produces here and makes a profit. Okay, now next condition, and so remember the condition was if price is bigger than average. Well, all right. Okay, condition two. So we're doing the same thing, but look at the difference. It all depends on how costly the production is relative to the price. So now the price is set here at price E. All right. So where's when MR equals MC for this firm? It's right. I mean, it's right there. See? Here's the marginal cost curve. Here's the MR curve. So the intersection is right there, and that's the Q they're going to choose, Q star. All right. See that? MR equals MC. Now, what is their revenue? Price times quantity. But look, the average total cost, the cost at that output, is higher than the price. So basically, this revenue minus this cost gives them this loss. So in this time, the cost is more than revenue. But the reason they still want to produce is because the average variable cost is how much they would produce, with selling one more unit, and they're still beating that. So just minimizing losses basically covers the fixed cost, and it's more profitable to produce and cover the fixed cost than just to shut down completely. So this is a loss minimization situation where the firm does their optimal condition, chooses quantity, but revenue is a little bit less than cost. Okay, so that is condition two, loss minimization. Condition three is figure 8.5, the shutdown case. So if price is lower than average variable cost, they're going to shut down. So look at this. Um, let's look at the optimal point for this firm where price equals MC, or MR equals MC, which is right there, right? See that? And this is their best Q star. So that's what they would choose. And let's see if they calculate their profits, which they wouldn't do anyways, but if they calculate their profits, here's the price times quantity, here's the revenue. And then here, this whole area is the cost. So basically, this we're saying here for this type of firm, or for this example, it's so much more costly to keep producing that the firm should just shut down because producing more gives them more of a loss than just covering the fixed cost. All right, so see how it really all depends on what the price is set by the market and how costly it is for the firm to produce. So in the first case, condition one, okay, firm chooses Q star where MR equals MC, makes a profit. Condition two, loss minimization, firm chooses Q star where MR equals MC, minimizes losses because producing is at least better than just, at least they're covering the fixed cost. And then condition three um, is where they should shut down because producing is going to give them more of a loss than just taking the fixed cost loss. So this should make total sense where the breakout point is average variable cost, right? Because we're comparing revenue and cost. So if we're here, right, and the price on the margin for another unit sold if they're getting, so the revenue they get is the price, and the cost is the cost on the average variable cost curve. So this is the variable cost, which means that this depends on how much output they sell. So if they sell one more unit, okay, it's costing more than the revenue they're getting. All right, so each time they sell more, it's costing more than the revenue, and they're not even covering the fixed costs because the on the margin, it's more costly than the revenue they get. So it should be clear that, or it should be, you should see, hopefully you can see that the reason why the average variable cost curve compared to the price is the comparison, because those are the comparisons on the margin. So if on the margin we sell one more unit and it costs more than the revenue we get, then it's time to shut down because each time we sell more, we're losing more. All right. So, and the reason why this case they're taking a loss but still producing more is because look, here's the average variable cost. So at least they're covering that. So at least the additional revenue is higher than they would get on the margin by selling more. So see how the marginal revenue is bigger than the marginal cost. In this case, it's not. So that's kind of the graphical scenario there. So we've got uh, if price is set above average variable cost, go ahead and produce and either calculate your profits or your loss minimization. But on the other hand, if price is less than your average variable cost, just shut down because you're on the margin, you're not even covering your each additional units you sell, or even that best case is worse than you're just is worse than just taking the loss of the fixed cost. Okay. All right. Hopefully that made some sense. Okay. Let's look at another example. Demonstration problem 8.2, in which we're going to check this condition. Okay. Here we go. So demonstration problem A2, let's suppose the cost functions. Let's suppose the cost functions for a firm are given below. If the firm sells in perfect competition at other firms in the industry sell at a price of 10, what level of output should the firm produce to max profits or minimize losses? And what's going to be the level of profits or losses if the firm makes the best decision? Okay, so let's first, so always for pure competition, just note that part A, or the initial part is just make sure you know your price. So if the price is set at $10, that's the price you gotta, so either that's the optimal price. So if other firms are selling at $10 for this good, it's a perfect substitute, so you can either sell at that price or not. So the price, P star, $10. Okay, that's given. Now let's find out if where the optimal output is. So MR equals MC. You know that MR is equal to the price, so that's going to be 10. In marginal cost, you have to calculate that based on the cost function. Okay, so 100 plus Q squared. Just differentiate that with respect to Q. So MC is DC, DQ. And if you differentiate that with respect to Q, you just get 2Q, right? Okay, and let's find MR equals MC. MR is price. Set that equal to MC. Price is 10. MC is 2Q. So the MR equals MC condition is when 10 equals 2Q. And find the Q there. Just divide by 2. And Q star equals 5. Now, is this a situation where the firm's going to keep producing? or they get a shutdown. So we need to check if the price 10 is bigger than, equal to, or less than the average variable cost at this Q. Okay? So average variable cost is simple to calculate. It's just the variable cost divided by Q. Um, you can see that the variable cost is the portion that depends on Q, and the fixed cost is the portion that does not depend on Q. So this doesn't depend on Q, so the variable cost is just Q squared. All right? So Q squared divided by Q, right? The average variable cost is just Q. Okay, so average variable cost is variable cost divided by Q. In this case, variable cost is Q squared. Q squared divided by Q is just Q. So for this firm, average variable cost, or ABC, is Q. Now, is average variable cost, let's compare that to the price. So the condition we want to check is price, optimal price bigger than, less than, or equal to average variable cost at Q star. So price is 10, average variable cost at Q star. So just plug in the Q star 5 for average variable cost, and that if you just put 5 in there, and average variable cost at Q star is just 5. So at least price is bigger than average variable cost at Q star, right? 10 is bigger than 5. So given that this condition holds, price is bigger than average variable cost, we know for a fact that the firm is going to keep producing because at least they're going to minimize losses. They might make a profit, but at worst, they minimize losses. Okay, now let's calculate profit or losses. So profit or losses is always total revenue minus total cost. Part C, revenue is price times quantity, and just subtract the whole cost function. Price is 10, quantity is 5, then minus the fixed cost of 100 and the variable cost of Q squared. 10 times 5 is 50, minus 100, and then minus the variable cost of 5 squared. Plug in Q there, and we get 50 minus 100 minus 25, and that should come out to negative 75. So this was a condition 2 where the firm produces but they minimize losses. And if this all makes sense, you should be able to check and see why this is the case. So so we know the firm's not going to make a profit, right? They're just their situation, their cost situation, and the market price just isn't going to give them a profit. But look, so they have two decisions: produce at Q star 5 or shut down. So if they produce at Q star equals 5, they take a loss of 75. If they shut down, their fixed cost is 100 and they lose 100, right? So when you do this and compare your loss minimization situation to the fixed costs, if you did the math right, it should be clear that they're doing the right thing. So losing 75 is better than losing 100 and just shutting down. So they're netting 25 by not shutting down, because shutting down would be minus 100 and producing is only minus 75. Now it's not great, but it's better than losing 100. Okay, so for this type of problem, you're going to want to check, you're going to want to do the same thing. The price is given, find Q star where MR equals MC, then go and determine if the price is bigger than average variable cost at the optimal Q. If it is, like it was here, they're going to keep producing. And then all you do is determine what their profit is or what their loss minimization outcome is. Okay. So the only additional step for this one was we did we checked this condition. All right. So questions on this one? Okay, so there's a little bit of math in these involved, but I think if you do I have a bunch of practice problems, including the homework, and so I think once you do this a few times, you'll get the hang of it. Um, okay. All right. So let's just make a note of what the firm's an individual firm's short run supply curve is going to look like, and so it's basically going to be the marginal cost curve above the minimum point on the average variable cost curve. So this should be clear based on the discussion we had. All right. So we learned that this is the break even point or the cutoff point. So if the market price is above the minimum point on the average variable cost, or if the market price when they choose their output, if the price is above average variable costs, they're going to at least cover their losses and they're going to keep producing. If the price is below that, then it's more costly to keep producing and they're going to shut down. So this is the break even point. So which kind of basically determines the firm's supply curve. So basically, like if this is the break even point, okay, if any point below here they shut down, they're not going to supply. If any point above it they produce, then they're going to supply. So basically, the marginal cost curve above the break even point is when they're going to start supplying. So any price above here, the firm supplies. Any point below here, they don't supply. So this portion, starting here, is the supply curve. Okay. So this part above where they start supplying, going all the way up when the price increases, if it does, is the supply curve, and this part is just they're going to shut down, which basically means they're not going to supply, and so only this portion, the red portion here, or the pink portion, is the individual firm's short run supply curve because that's the portion of the marginal cost curve when they would supply any point any price below there, they're going to shut down. Okay, so okay, and then so just long run situation is basically in the long run it's going to kind of break even. Or we're going to assume that with perfect information and perfect competition, that all firms kind of break even because like profit opportunities or loss minimizing or losses, profit opportunities will induce firms to enter the market, and when firms are taking losses, they're going to leave the market. So in the long run, we're going to get a situation where, in theory, the price always equals marginal cost for uh, the best choice, and then the price is going to be in the long run at the minimum point of the average cost curve because that's exactly the point when firms break even. Oops. All right, so see kind of if this is the market and if there's basically what the market price is only going to change if in the long run firms enter or exit. And so the idea here is that if a lot of so if this is let's go with the apples example. So if lots of firms are selling apples and making profits, that's going to induce other firms that have the resources to come into the market and start selling apples because it seems to be profitable. Now, if firms selling apples start losing money, and that's going to be an indicator that firms should start leaving the market, and you'll see some exit. So if it's a clear profit to be made, then other firms will come into the market and try to get some of those profits and push the price down. Or if firms are taking losses selling apples or whatever good it is, then firms will start leaving or exit the market, and that's going to push the price up. So basically, in the long run, we're saying that this is the equilibrium where the firms are operating right at this break-even point. Okay, so this doesn't mean this is uh, always the case. Clearly firms are going to make profits in the short run and take losses. So in all markets, especially in perfect competition, firms can make profits and firms can leave. They can shut down. They can take losses. So everything happens. But in the long run, we assume that with perfect information, all firms are kind of breaking even. If they didn't, then there'd be a profit opportunity, or there'd be losses. And if the loss situation, firms would start leaving the market, and the profit opportunity, firms would start coming in. So in the long run, with perfect information, this is exactly the kind of the break-even point. Okay, so that is perfect competition. Okay, next type of market is monopoly. All right, and so monopoly we know is a market structure in which a single firm serves the entire market for a good that has no close substitute. So there's only one seller of a good or service, and the consumers, if they want to buy that good or service, they only have one choice to buy from this firm, and so there's no other firm selling this good or service in this market. Okay, so we might have had some examples in the elasticity chapter, but let's just think if we can. So what are some examples of monopolies? So okay, so what? So can you think? Can anyone think of some examples of a firm or just a type of firm that's operating in a monopoly? So what are some firms that might be um, classified as a monopoly? What type of firm? What type of firm in which there's no close substitutes in which the customers can buy from? All right, so any ideas you can that someone wants to post to the chat here? Okay, well I guess the most common example is like utility companies, so public utilities. Okay, so public utilities like your electric company, most could be Edison, the gas company, most likely the SoCal Gas Company, or your local trash service could be a city thing, or the water service, which is probably also the city, or some local entity. So most places where you live, whether it's an apartment or a house, you really only have one option in which to get these services from, and you can't really shop around. So if you only have one choice, then that firm is operating a monopoly. So most of the time, these four things and most other type of public utilities, operate monopolies because the customer does not have a choice in which to buy these services from. They can either buy them or they cannot. In most cases, you really have to buy most of these things. Okay, so we're going to kind of go through the same exercise for monopolies and see how they make decisions, which are a little bit different than how a perfect competition firm makes decisions. So again, where the profit maximizing condition holds, they want to find their output in which MR equals MC. Okay, so again, like I'm not saying that every monopoly gets this 100% correct, but if they look at their spreadsheet and they see that when they increased output, they uh, got more revenue than cost, they would probably sell more output. If they saw on their spreadsheet that when they were producing more output, their cost was higher than their um, revenue, then they probably cut back. So this firms gravitate to this condition because they know that going beyond it, it's too costly or it's more costly, and not producing enough, they can get more revenue by selling more. Okay, so actually first let me show you how the demand curve looks a little bit different. So the demand curve looks pretty traditional here. Okay, so the demand curve for that a monopolist faces, and so take again that this is the like before we talked about an individual firm's demand curve versus the industry. Now, because there's only one firm selling this good or service in the industry, the individual demand curve is also equal to the market. So because the monopolist is the market, the individual demand curve and the market demand curve are the same thing. Okay, so the monopolist is going to face a downward sloping, likely steep demand curve because most of these goods and services are pretty inelastic because the consumer doesn't have a choice. And if your bill goes up for electricity or gas or whatever, most customers are going to pay the increase because they don't really have a choice. So most monopolies face a very inelastic demand curve. Okay, so the monopoly demand curve is likely very inelastic, which means that's probably downward sloping and pretty steep. Okay, you can see that here. So quite the difference from our perfect competition firm, where their demand curve was a horizontal line and is perfectly elastic. This demand curve is what we normally think of demand curves, downward sloping, where price goes down, demand goes up, price goes up, demand goes down. And so just think of a normal demand curve, but a pretty steep one because this is probably a very inelastic good. Again, because the consumers don't have much of a choice and they can't really shop around for goods or services that come from a monopoly. Okay, so what the monopolist is going to want to do is look for the same condition, right, where MR equals MC, find their best output, Q star or QM, and then choose their optimal Q. But then, uh, unlike the perfect competition firm, the monopolist gets to set its price. And so, given how much output they think they should produce, they're going to charge the price based on what the demand curve is at that output level. Okay, so see the difference? Step one is to find MR equals MC. So our MR curve is downward sloping here because, so think of it like this. So the marginal cost curve looks similar, but the demand curve is downward sloping, which means that the only way to get more customers is to lower the price. So see, if we're on a demand curve and if we lower the price, or if the price goes down, then you get more customers, but each additional unit sold is going to give you less revenue than before because you lowered the price. So the MR curve is downward sloping. Okay, so lowering the price gives the firm, we don't, I mean, gives the firm more customers because it lowered the price based on the law of demand. But again, every time you lower the price, your additional revenue for lowering the price for selling more goods goes down because you lowered the price, right? So the MR curve is going to be downward sloping, unlike the flat situation or the constant situation from the previous perfect competition. Okay, so here is our MR curve, and here is our MC curve. Now the condition we want to look for the monopolist is still what MR equals MC, which is right there. All right, that's the best output they can do, QM or Q star. Okay, so we find that. Then look at what they can do is take this, look at this output, go up to the demand curve and say, okay, this is the price we should charge PM based on selling this much output. So the monopolist has the ability to charge the price they think they should charge based on the demand curve. So first they're going to choose their optimal output, and then based on what demand is at that output, they're going to charge that price. Okay, and then most likely they're probably going to make a profit, and the profit is price times quantity, revenue, minus cost, average total cost at this QM. So this revenue minus this cost gives them this profit. Okay, so we'll do a little example of this in a second here. Or how about right now? So let's look at demonstration problem 8.4 and 8.5. We're not going to do the graphs, but let's go through the profit max exercise here for the monopolist. Okay, so there I put that condition here for the perfect competition that you can look at. So remember, to maximize short-run profits, a perfectly competitive firm should produce in the range of increasing marginal cost where price equals marginal cost, provided that price is bigger than average variable cost. If price is less than average variable cost, the firm should shut down its plant to minimize its losses. So that's from the last type of market, but I put that there. Okay. For monopoly, demonstration problem 8.4. Let's suppose the inverse demand function for a monopolist product is given below. What is the maximum price per unit a monopolist can charge to be able to sell 3 units? And what's the marginal revenue when Q equals 3? So here's the demand curve. Okay, price equals 10 minus 2Q. That's just the downward sloping demand curve, right? Negative relationship between price and quantity. So question is, what's the maximum price per unit a monopolist can charge if they want to sell 3 units? So if they want to sell 3 units, just plug in the 3 into the demand curve right there. So there's the demand curve, but Q is 3. Just plug it in. So we get P minus 10 P equals 10 minus 2 times 3. P equals 10 minus 6. And based on the demand curve, if you plug in 3 units, the price they should charge for their best situation is $4. Right? 10 minus 6 is 4. Okay, so for a monopolist, once you solve for Q, plug that Q into the demand curve, and then that's the price you should charge. Now, let's calculate revenue and then marginal revenue. So this is price. Okay, so revenue is price times quantity, right? P times Q. Now, this is P, right? 10 minus 2Q is P. And so P times Q, which means if you plug in 10 minus 2Q for P, right? Then this is P times Q. And if you multiply across, so total revenue is price times quantity. Plug in our price of 10 minus 2Q, and we get total revenue equals 10 minus 2Q times Q. Distribute the Q, and we get total revenue equals 10Q minus 2Q squared. But we know that marginal revenue, you have to differentiate this with respect to Q. Okay, DTR DQ is your marginal revenue. So how revenue changes on the margin when you change Q by 1 unit is MR. And if you differentiate TR with respect to Q, that's MR. Okay? So differentiate this with respect to Q, and we get 10 minus 4Q. Okay? So the MR curve is 10 minus 4Q, and the question was, what is MR when Q equals 3? Just plug in 3 there. So MR of 3 is 10 minus 4 times 3. It's 10 minus 12, so marginal revenue at Q equals 3 is negative 2. Okay, let's also do demonstration problem 8.5. We'll do the whole exercise with the monopolist. Okay, so basically this one we're gonna do the same exercise to find price, quantity, and revenue. I mean, price, quantity, and profit for the monopolists. The only difference is they get to choose their price as opposed to the perfect competition firm where they did not get to choose their price, only their quantity. So like an extra step here. So let's suppose the inverse domain function for monopolists and the cost function are given below. Let's determine the profit maximizing price and quantity and the maximum profit. So here's the demand curve. Here is the cost function. And remember, that is fixed cost, and that is variable cost. Okay, so the monopolist would like to find the situation, the Q, that satisfies MR equals MC. So before we find that condition, we got to find MR, and we got to find MC. Okay? So total revenue is always P times Q. This is P. So P times Q is 100 minus 2Q times Q. If you distribute the Q, you get 100Q minus 2Q squared. And if you differentiate this with respect to Q, that's MR, and that would be 100 minus 4Q. So that's MR, that's going to go right there. The cost function is 10 plus 2Q, that's given. And if you differentiate that with respect to Q, that's exactly marginal cost. So if you differentiate this with respect to Q, it's just 2. So that's going there. So MR equals MC. MR is 100 minus 4Q, and MC is 2. So if you solve for Q, if you subtract 100 from both sides, you get 4Q equals 98. Divide by 4. 98 divided by 4, we get optimal Q star is 24.5 units. All right, then what price should the monopolist charge? Just take the output they want to charge Q and plug that into the demand curve. So here's the demand curve, P equals 100 minus 2Q. Let's plug in our Q of 24.5, so we get 100 minus 2 times 24.5, and that's 100 minus 49. And so the price, the demand curve tells us the price we should charge given this much output selling is $51. Okay, 100 minus 49. Now all you got to do is calculate the profit, which is total revenue minus total cost, given this Q and this P. Okay, total revenue is price times quantity. The cost, the total cost is the cost function. Price is 51 times output Q is 24.5 minus the cost function of which was given 10 plus 2Q. 51 times 24.5 is 1,249.5 minus 10 minus 2 times Q of 24.5, and profit is 1,249.5 minus 10 minus 49. And if you do this math, you get the monopolist here gets a profit of 1,190.50 cents. Okay, so basically the only difference here is we want to find for a monopolist, MR equals MC, and then find Q star. Then plug the Q star into the demand curve and find the optimal price. And then based on the price and quantity, just calculate profit, which is revenue minus cost. Okay, so the exercise for the monopolist, questions on what we did here? All right, everyone good so far? Okay, so we have one more type of market to talk about, which is called monopolistic competition. You might have heard about this or learned about this type of market in BUS525. So this type of market, monopolistic competition. So monopolistically competitive market is a market in which there's many buyers and sellers. Each firm produces a differentiated product, and there's free entry and exit. So this is the key here, where firms are selling the same type of product, but it's slightly different. So it's like Coke and Pepsi, or different types of toothbrushes, or different types of cars with different features. But there's firms competing for the same type of good, but there's different brands and different types of features that separate that firm's product from other firms selling similar products. Okay, so because the previous two markets we talked about, there's not much advertising because number one, that the price is the price for private competition, and for monopolies, they don't really need to advertise because they already have all the customers they can get. There's nowhere else they can shop around. But for monopolistic competition, if you're selling Coke and Pepsi, or you're selling different types of shoes or different cars or different toothbrushes, you might want to advertise because you can get customers to come away from, or hopefully get customers to come to your product because you offer something a little bit different, or they like your brand, or whatever. Okay, so we're not going to talk too much about advertising today, but there are different um, types of advertising that can come with this type of market. Okay, one type is comparative advertising, and this is where you're trying to differentiate your good or service with by saying like this is th- this product has different, like if you're looking at like a, I don't know, like cars in the like the 30,000 or $40,000 range, you can say this car has Wi-Fi, this car has heated seats, this car has the the best safety rating. So different features that might set your product apart from other sellers. All right, there's also just brand equity, which means that your product, especially compared to like generics, might have some value just based on the brand. So if you're looking at like Coca-Cola, just the brand itself has some additional value compared to like generic soda. And if you're looking at like Band-Aid brand bandages, they have some additional value just based on the brand compared to like Target brand bandages, stuff like that. So the additional value from just having the brand that's known is the brand equity. Okay, there's also some other types of marketing. So there's like niche marketing, if I pronounce that right, which means you're targeting a specific type of uh, consumer, which would most likely buy your product. So you'll definitely see like different types of advertising if you watch TV at different types of the day. So if you watch like the news in the morning, you'll see a lot of advertising for like drugs and like medical products because they're assuming that more of their audience is in general older, I guess. Um, and if you watch later night TV or if you watch sports, you'll see like none of that. You'll see a lot different. You'll see car advertisements. You'll see depending on the the sport you're watching, you'll see lots of like social justice marketing advertisements. And so they really try to. So niche marketing is given the audience that they think is going to be watching the show or the program. You'll definitely see that the types of goods and services advertised are different. Okay, and then if you're a good or service that's looking at trying to get customers that are interested in environmental or things that are good for the environment, to help global warming, help carbon emissions, stuff like that, you can go for green marketing, and lots of cars are going for this now, and lots of companies are saying they're uh, carbon negative or going to be carbon neutral, stuff like that. So there's a whole specific type of green marketing campaigns that focus here. Okay, and then advertising. So there's arguments for advertising. Clearly, it gets information across. You can compare you can get your product compared with other goods and services, provide information to the audience. Um, Arguments against advertising, the information can be misleading. You can get things like where you see uh, if you see like an advertisement for internet service, it says like 49.99, but that's only if you bundle it with like four other things. So a lot of times, like the big picture price or the big picture feature is only if you satisfy a bunch of other information. So it's not always 100% honest. So it can be misleading. Okay, so there's a whole bunch on advertising in the chapter. We'll do a little more on advertising in the oligopoly chapters, the next couple chapters. But I just kind of want to introduce it now because in the monopolistic competition markets, there's quite a bit of advertising. I think I still have one more demonstration problem to do, but let's wrap up the slides here. Okay, so we learned about three whole different types of markets here: perfect competition, monopoly, and then lastly, monopolistic competition. There's two whole chapters on the other type, which is oligopoly. In chapter 9, we're going to look at that. And again, with chapter 10, we're going to look at some game theory aspects and kind of go into a lot more detail on the other type of market, which is oligopoly. So that's for next time and then the next time. Okay, so one more demonstration problem, and really the only difference between, well, for solving the problem, the only difference for monopolistic competition versus monopoly is that the demand curve is flatter because the consumers have more choices. So that's really the big difference. So let me write that here. Okay, so most importantly for this type of market, the firms sell differentiated products, which means like, okay, so those are all shoes, right? Consumers are buying shoes, but they're different types of brands and different types of shoes, but they're all selling shoes. So different types of shoe products, right? So those will all go into this type of market because it's not the same exact thing, but they're all shoes. So they're slightly differentiated shoes or whatever type of market you're looking at. Okay, and then also compared to the monopoly, so compared to monopoly firms for monopolistic competition, okay, so the demand curve for a monopolistic competitive firm is going to be downward sloping, but much steeper and much more elastic. I'm sorry, much flatter and much more elastic. And that's because the consumer has options and they can shop around. And so if just look at like the shoe example, um, okay, if the consumer is looking to buy shoes and they're comparing Nike, Adidas, and Vans, and the price of Nike doubles, they're probably going to lose some customers to Adidas or Vans or other shoe companies because they can buy a cheaper option. It's not the same exact thing, but if you increase your price too much, you're not gonna retain your customers because they have the option to shop and buy different brands and different products. Now, for Monopoly, for like the electricity company, if they raise your rates for electricity, not much you can do except for use less than pay the price, because there's no, you couldn't like cancel Edison and get electricity from Amazon. There's no other companies, and so that's why, given the amount of choices, no choices for monopolists, so your demand curve is steeper, and lots of choices for this type of market, and so much flatter, more elastic demand curves. Okay, so last example for the demonstration problems. So demonstration problem 8.7, let's suppose the inverse demand function for a monopolistic competitive firm's product and the cost function are given below. Let's determine the price, quantity, and profits. So here's the demand curve. Here's the cost function. And again, we want to find the profit maximizing condition where MR equals MC. Okay. Uh, so first we need to find MR and MC. So let's start with total revenue. Total revenue is price times quantity. And this is price. So total revenue is price, 100 minus 2Q times Q, price times quantity. Distribute the Q, and we get 100Q minus 2Q squared. And if you differentiate this with respect to Q, that's MR. So MR is 100 minus 4Q. All right, the cost function is given 5 plus 2Q. If you differentiate cost with respect to Q, that's marginal cost. And so differentiate that with respect to Q, and that is just 2. So MC is 2. So MC is 2 and MR is 100 minus 4Q. Plug those in here. MR is 100 minus 4Q, that equals MC, which is 2. And let's solve for Q. So move, add 4Q to both sides and subtract 2 from both sides. We get 4Q is 98. And just divide by 4. And again, Q star is 24.5 units. All right, so what price should they charge? Plug this Q into the demand curve and charge that price. So the demand curve is 100 minus 2Q squared, that's given. Plug in the Q of 24.5 and solve for P. 100 minus 49, and the optimal price is 51. Okay, now just calculate the firm's profits, which is revenue minus cost. Total revenue minus total cost. Total revenue is the price times the quantity. Subtract the cost function. Price is 51. Quantity is 24.5 minus 5 plus 2Q squared. And 51 times 24.5 is 1,249.5. And make sure you distribute the minus here. So minus the fixed cost of 5, minus the variable cost of 2 times Q, and plug in your 24.5. Profit is 1,249.5 minus 5 minus 49, and we get a profit for this monopolistically competitive firm of 1,195 and 50 cents. Okay, so in terms of doing the math, the process for this versus monopoly is very similar. Find MR equals, or actually first find MR and MC. All right, then set MR equal to MC and find Q star. And then take your Q star and put it into the demand curve and find P star. And then just calculate profit, which is total revenue minus total cost. Total revenue is just the optimal price times the optimal quantity minus the cost function at Q star. Okay, so questions on this one or any of these uh, demonstration problems where you're finding the best quantity, price, and profit if they get profits? Okay, so if you're at the Chapter 8 section and you look, here's the homework for next week. Homework Chapter 8. If you open that up, okay, it looks like this. So there's three questions, and I believe, so I try to set it up where you're doing the profit maximizing exercise for each of the types of markets, and one of them is, so so basically it's going to go like you get uh, a cost function and you might get a demand curve. And so if you don't get a demand curve, it's most likely perfect competition because there is no demand curve. Demand is just the price. And so basically you get some information on the equations, and then part A, well, depending, um, part A here is, all right, so hold on. So number one, you get a total cost function. So this firm's a price taker, so you know they're going to be perfect competition. All right, so you know the price. And then you want to set MR equal to MC and find Q star. In part C, remember if you want to check if the firm should produce or shut down, you want to see if this condition holds at the optimal Q star like we did in the examples. Then calculate profit or losses. And then the last statement, part E, is going to say this firm sells something or does this. What type of firm is it? Or what type of market is the firm operating in? Okay, and then number two, you get a demand curve, a total cost function. You're going to find Q star by setting MR equal to MC. You're going to find the market price by putting the Q star into the demand function. You're going to see if the firm should keep operating by seeing if this condition is satisfied. Okay, part D, calculate profits or losses, and then part E, you get some statements saying this firm sells cereal. What type of firm is this? What type of market is this firm operating in? Okay, and then one more. So another demand curve, another total cost curve. Um, Set MR equal to MC and find Q star. Then plug in Q star equal in the demand curve and find P star. See if this condition holds, which determines if this holds, then they should keep producing. If not, they should shut down and get profit or losses. And then finally, this firm is a public electricity company. What type of market is this firm operating in? So one of these is going to be perfect competition, one's going to be monopoly, and one's going to be monopolistic competition. Okay, so it kind of sums up all uh, the whole exercise for each type of market and one nice little homework here. Okay, so questions on the homework assignment or what I want you to do for this one? Okay, well, so this one is due, this assignment's due next Monday. And if you have any questions or need help, you can feel free to send me an email. All right, and so just a reminder, the homework chapter 5 is due tonight, and so make sure you get your chapter 5s posted here if you haven't done that. Email me your midterm answer sheet if you haven't done that by tonight, and then this is due next week, where you're going to post your chapter 8 homework right here. So, okay, so we're just about done. Okay, so again, this is due today. This is due today, and then this is due next week. Homework chapter 8. So we'll next week. Your chapter 8 homework is due in the discussions, and then we're going to cover a different type of market, which is oligopoly, and that's going to be chapter 9. So if you have the textbook or you're reading ahead, we're going to be doing chapter 9. And so next week, July 19th on Monday, we're doing chapter 9, oligopolies, and then also this week's homework is due then. Okay, and so just if you have any questions on the homework or anything else, let me know, send me an email, and I'm happy to help. But I think that's what I wanted to cover for today. So if there's no more questions and everyone's gotten the homework and all the other assignments, uh, that's it for tonight's meeting. And thank you all for coming. And I'll see everyone in a week, next Monday, same time. So thank you and have a great week.